So now that we have the fundamental identities under our belt, we need to recognize, first of all, what an identity is, and then how we're going to prove some of our other identities using them. An identity, what the definition of an identity is that if I pick a value of theta, let's say that I pick pi over 4, that the tangent of pi over 4 will always give me the same value as sine of pi over 4 divided by cosine of pi over 4. Now we've played with that, we've practiced with that. You should be very aware that this is always true. The same can be said for all of these other identities. If I pick a value of theta, pi over 4, pi over 6, 12 pi over 19, as long as I use the same value of theta on both, in all of my arguments here, all of my inputs, that both sides of the equal sign will give me the exact same results. That's what an identity is. If we look a little further and I were to say, I have this set of functions, which is cotangent of theta divided by cosecant of theta. What is a simpler way of writing that would give me the same answer? Establishing identities is all about simplifying what we have to a simpler problem that will always give me the same answer. A very basic example of that would be if I had 3x plus 2 plus 5x, and I were to tell you that that was equal to 8x plus 2. You can easily see that if I took the left side and I used simplification, where 3x plus 5x is 8x, that I could, this is a much simpler way of writing this information. And if I plug in a value of x, let's say I plugged in the value 3, the left side and the right side of the problem would always give me the same value. That's an identity, that no matter what I plug in for the value of x, I'm always going to get the same answer on either side. Not just some answers, but every value of x. So if I were to look at this and I wanted to simplify it, one of the first things we try to do is see, can we simplify it down to either not a fraction at all or down to just sine and cosine. And by taking cotangent, rewriting it with cosine over sine. So I'm going to rewrite that. I'm going to take the cotangent of theta over cosecant of theta, and I'm going to rewrite this as cosine of theta over sine of theta over, and now what is cosecant? Cosecant, remember, is the reciprocal of sine. So I can write that as 1 over sine of theta. Now I know you're looking at that going, well, wait a minute. To simplify it, you just made it more difficult. That's true. They both now have the same denominator though. And remember, I am allowed to eliminate a denominator as long as I multiply the top and the bottom of my fraction by the same thing. That cancels and that cancels. And what does that leave me with? This whole thing right here will give me the same exact value as any cosine of theta. So the cotangent of theta divided by the cosecant of theta, which would be some numbers I might have to figure out and calculate, I can simply plug that theta into cosine and find an answer. Prove it to yourself. Take pi over 3. Find the cotangent of pi over 3. Find the cosecant of pi over 3. And you're going to find that that equals the cosine of pi over 3. This fraction is going to equal 1/2. Well, guess what? So does the cosine of pi over 3. Much easier to work it as cosine of pi over 3. So establishing identities is about proving that two sides of an equal sign are exactly the same thing so that we can use it later when solving gets more difficult. Sometimes we have to make it more difficult to make it easier. Let's look at this problem. This is very similar. We've got a fraction. They've asked us to simplify it. The first thing I'm going to try and do is see, is there anything I can do in the fraction itself? And in this case, there's not. So let's rewrite tangent of theta over secant of theta equal to sine of theta over cosine theta over 1 over cosine theta. What do they both have in common? They both have a denominator of cosine theta. So I'm going to multiply both the top and the bottom part by cosine theta so that I can cancel that out. And what is that equal to? Sine of theta. We have simplified tangent of theta over secant of theta is equal to the sine of theta. Now sometimes they tell us exactly what they want us to do when we're simplifying. In this problem, they're wanting me to prove that the left side is equal to the right side. Well, that's a little tough to do unless I take the left side over here and I'm going to multiply the top and the bottom by 1 minus sine of theta. So I'm going to multiply 1 minus sine of theta over 1 minus sine of theta. Does anyone recognize the relationship in between these two? If you look at it, this is 1 plus something, 1 minus something, and those were called conjugates. Remember conjugates when we had to, conjugates, sorry, and had an extra A in there, conjugates. When we had to multiply 1 plus I times 1 minus I, those were conjugates. The reason we did that was to get rid of the middle term. Well, when we multiply these two together, we're going to get 1 minus sine times 1 plus sine is 1 minus sine squared theta. It eliminated the middle term. And on top, I've got cosine of theta times 1 minus sine of theta. We're not going to worry about distributing that out right now. I'm going to have to move down because I run out of room there. So now look at this identity, 1 minus sine squared theta. Look back at our fundamental identities. Do you see anything that looks like 1 minus sine squared theta? Look around in here in the Pythagorean identities, and we see that 1 minus sine squared theta is really a spread out way of writing cosine squared theta. So I'm going to go back to my problem and replace this with cosine squared theta. I've got cosine of theta on top times 1 minus sine of theta. The cosine cancels out with one of those, because remember cosine squared is times cosine, cosine. Cosine squared is cosine times cosine, so I canceled out one of them, leaving me with 1 minus sine of theta over cosine of theta. That's the second half. This is now equal to the second half. I converted the first half into the second half of the problem. And therefore, cosine of theta over 1 plus sine of theta has been proven to be equal to 1 minus sine of theta over cosine of theta. Now, you can't just magically state that. You have to mathematically prove that they are actually equal. And that's called establishing the identity. And this unit is trigonometric identities. Let's look at this next one. Works the same way. We're going to take the left side of the problem. We're going to multiply the numerator and the denominator by 1 minus cosine theta. That's going to give me sine of theta times 1 minus cosine theta for the top, and 1 minus cosine squared theta for the bottom. Now remember, go back and look at our identities. 1 minus cosine squared theta is a stretched out way of writing sine squared theta. So I'm going to substitute and write sine of theta, 1 minus cosine theta all over sine squared theta. We can cancel out, and that gives me 1 minus cosine theta over sine of theta. And we have established that the left side of the identity can be converted into the right side, and therefore sine of theta over 1 plus cosine theta is equal to 1 minus cosine theta over sine of theta. That is establishing identities part 1.